All right, here we go. Gas stoichiometry example. So we just learned about molar volume, and we've learned that at STP, we know that 6.02 times 10 to the 23rd molecules or atoms of a gas has to occupy 22.4 liters. And so we are going to do this stoichiometry problem. So first of all, again, first step, you need to write a correctly written chemical equation and balance it. So let's do that. So what are we given? We are given the fact that we have a, it says what volume of hydrogen at STP can be produced. So it looks like I have H2 as something in gas form being produced, okay, on the other side, the right side of the equation, when 6.54 grams of zinc, so we have solid zinc, so that's Zn. Good idea to put your states if you can, okay, so it's definitely solid because we've got a mass there of zinc, and it's reacting with hydrochloric acid. Okay, so we've got plus HCl. Okay, now that's all the question gives me. That's all the question gives me. And maybe, I don't know if you guys got stuck on this first part or not, but if that's all you wrote, we have something wrong with this equation. It's missing something, right? So let me just reread that. What volume of hydrogen can be produced when zinc reacts with hydrochloric acid? I've got zinc reacting with hydrochloric acid producing hydrogen. Well, where does the zinc go? Where does the chloride go? We're missing something. So you should have noticed that we have to combine zinc and chlorine as another product over here, okay? Now, zinc, if you look on your periodic table, zinc has a +2 charge. So I need to write a correctly written formula with zinc, 2+, and then mixes with chlorine, 1-. So guess what? I'm going to have ZnCl2. Okay? So there's the first tricky part there. You need to write a correctly written chemical equation. So now we have all of the atoms accounted for. Let's balance them. So my zinc, I have one zinc. Great. I have one chlorine, two chlorines. So guess what? I have to do this. I'm going to put a 2 there to balance the chlorines now. And that affects my hydrogens. So let's check the hydrogens, 2 H's, 2 H's. Awesome. Looks like I'm pretty good to go here with this molar ratio. Let's just double check. 1 zinc, 1 zinc. 2 chlorides, 2 chlorides, and 2 H's, 2 H's. Okay, so we're good. So that's our correctly balanced equation. Okay. Now what we're going to do is we're going to do stoichiometry. So I am given 6.54 grams of zinc. Where's zinc? There we go. 6.54 grams. And again, it's it's highly recommended that you draw these little arrows and make your little spaces, map out where you're going here. Okay. This is always what we do for stoichiometry. We always convert to moles. Then we use the molar ratios in the equation to convert from moles to moles. Okay. Now we're going to go back up, but watch this. We usually go back up to grams, but we don't want grams. We want what volume. This is hydrogen. Obviously it's gas because it's talking about STP. So I need to go here and I need to, what volume of gas? So this is going to be in liters. Okay. So this is the map, and this is what we need to do. So 6.54, that's going to be divided by the mass of zinc on the periodic table is 65.39. So you're going to get your calculator out, and you're going to go 6.54 divided by 65.39. And what does that give me? 0.1. Okay, so there's a bunch of zeros there, so that's pretty much 0.1. 0.10001. If you want to do that, that's great. Okay. So we're going to use all those decimals anyways, but this is what we'll write down. So we got about 0.1 moles there. That's awesome. Now I need to go to hydrogen. So remember what you do here is you take a look at this molar ratio, this part of the ratio. That's a 1, and this that we're coming from is also a 1. That's awesome. You multiply by this divided by this one. So it's a 1-to-1, so do you need to write 1/1? Not really. But you know that this is going to be the exact same number over here. And that's the moles now of H2. So this is moles of zinc, that's moles of H2. Hopefully you're good and you're following me. And this is what you got so far. All right, now what we're going to do is we're going to go back up to liters. Okay, so here's the new thing, right? This is the new thing. I'm not going to grams, so I don't need to find out grams per mole. I'm not going to particles, so I don't need to multiply by Avogadro's number. What I need to do is you need to go back up to your chart that we just learned about right here, and we're going from moles here to liters. So what do? We multiply by 22.4. That's it. Multiply by 22.4, which is actually liters per mole, as you see, right? Oops, right here. Oh my goodness. 22.4 liters per mole. So, I'll do this in black here so you can see. Times, so this number times 22.4. This is moles, this is liters per mole. The moles are going to cancel out. We're going to be left with liters. Awesome. So I'm going to get back on my calculator. I'm going to use that whole decimal like a good little boy I am. And I'm just going to go times 22.4. Okay. Multiply going away from moles always. So 2.2403. What did I just say? 2.24. 2.240303. So I've got 3 sig figs given in my measurements. So if I'm wanting to know how many sig figs I should use in my answer, we should go with 3. So that's going to be 2.24 what? Liters of what? H2. Make sure you have your number. Make sure you have your units. Make sure you have your substance. Okay? And if you want, you could say produced. Whatever. But that's all I'm looking for. Number, units of what substance. Okay? There's your gas stoichiometry example. Does anybody have any questions? I will take those now from my class that are online right now. Okay, good question. How did I get 65.39? This is the grams per mole of zinc from your periodic table. Yep. Awesome. Any other questions? All right, there you go.